Okay, so picture this. Right now, somewhere out there, a black hole is just waiting. And you, hypothetically, are falling toward it. Not jumping, not choosing, just falling, the way you'd fall off a curb, except the curb is the size of a solar system, and the ground never arrives. Here's the thing nobody tells you about falling into a black hole. It doesn't hurt. Not at first. Not for a long, long while. You don't feel a slam, you don't feel a wall, you don't even feel the moment everyone back home would call the end. You just keep falling, and keep thinking, and keep being you. Let's slow down and actually walk through what happens to your mind, second by second, because the real horror isn't the black hole, it's how normal everything feels while it's happening. So first, you cross something called the event horizon. This is the point of no return, the invisible line where gravity becomes so strong that not even light can climb back out. You'd expect a boundary like that to feel like something. A jolt, a flash, a cosmic, you have now entered the danger zone chime. But it doesn't. For a big enough black hole, especially a supermassive one like the kind sitting at the center of our galaxy, the event horizon is so gentle that you'd sail through it without any local sign at all. No bump, no flash, no sensation whatsoever. Which means, from your perspective, floating there in your spacesuit, thinking your normal thoughts, you would have no idea you just passed the point where the universe has already decided you're not coming back. You'd still see stars. You'd still see your own hands. You could do math in your head, hum a song, remember your mum's voice, all while being, according to physics, unrecoverable. Now here's where it gets strange. Because someone watching you fall in from a safe distance, say a friend orbiting nearby in a spaceship, would see something completely different. To them, you'd appear to slow down as you approach the horizon. Slower and slower. Your image would stretch, redden and dim, like a photo fading at the edges, and you would seem to freeze there, forever, never quite touching the line. They would never actually see you cross it. As far as the outside universe is concerned, you get smeared into a kind of eternal photograph, frozen at the edge of the abyss. But you, the one actually falling, you experience none of that. Your watch keeps ticking normally. Time feels completely ordinary to you, because time always feels ordinary to whoever's inside it. This is the wild part Einstein handed us. There is no universal now. The you that's falling and the friend that's watching are experiencing two entirely different timelines of your death, and both of them are correct. So you keep falling, thinking clearly, feeling calm or terrified or bored, whatever emotion your brain happens to land on, and your brain does keep working. Neurons still fire. Electricity still moves through you the same way it always has, because locally, in your immediate little bubble of space, nothing is different. This is actually a real principle in physics, called the equivalence principle, and it means that free fall, even the falling into oblivion kind, feels exactly like floating peacefully in zero gravity. Your body cannot feel curvature, it can only feel force, and in free fall, there is no force. So your mind, tragically, gets to keep working right up until it very much shouldn't. But eventually, and this is the part depending on the size of the black hole, could take seconds or could take hours, gravity stops being gentle. As you get closer to the singularity, the crushing point at the center where everything currently known about physics simply stops making sense. Gravity starts pulling harder on your feet than on your head, assuming you're falling feet first. The difference becomes so extreme that your body starts to stretch. Scientists actually call this spaghettification, which sounds like a joke, and honestly kind of is one, except it's happening to you. Your legs get pulled away from your torso faster than your torso can follow. You stretch into a thread of atoms, then a thread of particles, then something that doesn't really have a name because no human has ever survived long enough to name it. And through all of this, here's the truly unsettling part. Your brain, for a shocking amount of that stretching, is probably still working. Neurons don't need your whole body to fire, they just need local electrochemical gradients, and those keep functioning even as the rest of you is being torn apart by gravity's difference in pull. So there is a real, physically plausible window of time where you are aware, where you are still you, stretched, dying, beyond any hope of rescue, and still thinking. What are you thinking about in that window? Nobody knows, no one's ever come back to describe it. Some physicists think consciousness would blur out fast as sensory input collapses into noise. Others think because time dilates so severely near a singularity that final moment could stretch out subjectively, a few real seconds feeling like an unbearably long stretch of experience. Not because anything is being kind to you, just because the math of space-time does that. And here's the truly cosmic joke buried in all of this. From the outside, you already died the moment you crossed the horizon, frozen there forever in the eyes of the universe. But from the inside, from your point of view, you're the last one to know. You get to keep existing, keep thinking, keep being a person with memories and preferences and a favorite song stuck in your head long after the rest of reality has quietly filed you under gone. That's the strange, almost tender horror of black holes. They don't erase you all at once. They let you keep being yourself for just long enough to realize slowly that being yourself doesn't matter anymore. Space-time doesn't care about the difference between still thinking and already lost. It just keeps stretching and pulling and folding you toward a point where even the laws of physics throw up their hands and stop trying to describe what happens next. So next time someone says nothing can prepare you for death, remember, if it's a black hole, something absolutely could. Physics already wrote the whole story. You just don't get the ending, because there isn't one. Not one anybody's ever seen, not one anybody ever will.